important of statistics in data analysis. Okay, so the outline of today's presentation is the basic terminologies which are required for statistics, data analysis, then talking about what is the data analysis process, why it is important. Actually, this is just a points which I will explain you, but I have already shared the 3 PDFs, some books and some presentations which I have used to make this slides. So it will be helpful to you to read to read those and get a complete analysis, like what exactly the every process is. Because in an hour, I cannot explain you everything, but I will try to cover maximum. So data analysis process, then statistical analysis, and it's important. Then ANOVA, ANOVA is one of the basic technique that every researcher used when they do the statistical analysis. And statistical analysis is not only done in computer field or in data analytics, it is done in every field, even economics. I have many clients from different, from foreign countries, from different various countries, where I perform the data analysis for them in economics field, in finance field, in management, then in HR, everywhere. Everywhere, lot of data is there. To get the insights, you have to perform the data analysis, and statistics is the foundation of it. So ANOVA analysis is the basic technique which is used by all researchers. That's why I am pointing to this. Then I will just give you a simple example. How the data, how we collect the data. Actually, I have used the open source data set for this session. So which data set I'm using for the analysis, I will show that. Then what is hypothesis testing? Most of you might be knowing about the hypothesis testing, but if you don't know, I will explain you what is hypothesis testing, because most of the research PhD students, they have to, based on the research questions, they have to create the hypothesis, which is a statistical part for their research. They have to show, if you want to do the quantitative analysis for your research, it's important to do the hypothesis testing. So what are the steps for it? Then what is the, how to get which data is more important to you than the other, to get how each feature, like we call it feature, one column in our data, we call it feature in machine learning. So like which feature is more important, that I will show you using 2 different tools, SPSS and Orange. But today it is not possible because I am basically trying to explain you the complete process. So I will go theoretically, but I have included the screenshots of these tools that will be helpful to understand how the result is obtained and what insights you can get from that results. Okay, then last is correlation, Pearson correlation we will see. So this is the outline of the thesis. Now it's a basic, just have to close these windows. Okay, so the basic terminologies. So the basic terminologies of the statistics, or we can say maths, or we can say data science, or we can say AI, or we can say ML, anything. Everything is similar, but they are different. So how they are different, how they are similar? So I'm giving you a broad aspect of how AI, statistics, mathematics are together and how they are different. The first is statistical analysis. So what is statistics? Statistics is a branch of mathematics. It's a branch of maths which is concerned with the collection, analysis, interpretation, and visualization of data, empirical data. Empirical means you have a raw data which don't have any information, but like you have to, by looking at the data, by doing visualizations, by doing analysis, you have to extract the meaningful information among it. Then next branch is data science or data analysis, which is nearly a same. So it is a study of data. What we are studying in the data, how to clean the data, because the data that you are getting is a raw data. Raw data means you don't have perfect data so that you can gain the insights from it, to gain the useful information from it. So to extract the useful information from the data, you have to first clean it, then you have to process it, you have to analyze it. So this is the complete process that we do in data analysis. Okay, and finally the upper level hierarchy shows it's a machine learning, artificial intelligence. So machine learning is a branch of AI which is used by data scientists to enable the machines to learn automatically from the past data. So right now we are not focusing on this. This is the upper level hierarchy. We are focusing on this point, statistical analysis and data analysis, how they are related. But this is the upper level hierarchy that we can have a next section on it. So we can talk about it more. So how they are related? From this diagram, you can see the upper yellow part is a complete mathematics and statistics. Okay. And this is the complete part which is talking about AI, which is artificial intelligence. Artificial intelligence is completely dependent on data. So data is very important for AI, and ML is a sub branch of AI. Deep learning is again a sub branch of ML, which is a sub branch of AI. And all are collided with a data science, which is data analysis. So mathematics and statistics. So for data analysis, data science, you have to take the supports of maths and statistics to gain useful information from a raw data, else it is not possible. Okay. So let's move to the next part, that is data analysis process. What is a data analysis process? Okay, so the data analysis process, the first step is identifying the problem. You have to identify a problem, what you want to study. Like for example, suppose I have a simple problem like from a data, I have a data of students. In the data, I have their age, their name, their class in which they study, and their division. Okay. And I have their hobbies as well. Okay. So I have few data. Now, my problem, what for the student data set, what will be my problem? My problem will be which student is good in which subject. I have marks of different subjects, math, science, economics. Okay, so I will find which group of students are having best marks in which subject. Okay, so now see, if I'm giving this data to some university, how they will use that data? I will identify a problem as that like if a particular student is good in economics, he or she can further do the studies in economics at the higher level university. If someone is good at mathematics, he can move into statistics, statistical analysis. If someone is good in science or someone is good in medical biology part, okay, they can pursue their studies in medical. Okay, so to give the suggestions that you are good in this studies, you have to analyze the data of last few years. If I have a data of a student of last 5 to 10 years, then continuously I can observe that out of 10 years, this particular student is good in maths for consequently 6 years, or for 6 years or 7 years, then I can suggest you are good in maths, go for this branch. So this is the problem that we have identified. The problem is guiding the students to in which field they should move on in the university. Okay, so first we have to identify the problem. Then you have to collect the data. See, collect the data means you have to collect the data from where? In our case, in our example, we will collect the data from university. From some school. From some school, because we have to suggest that a particular student should go in this field in university. So we will collect the data from a school. Okay, then after getting a data, like we have to clean the data. Clean the data means for some of the students, I have the student name, I have the marks of maths, I have the marks of science, but I don't have the marks of biology. I don't have the marks of economic subject. So this is the missing information. So for such cases, I have to fill this missing information to do the analysis. I have to randomly fill, like there are various data analytics processes that we use to fill the missing information. Sometimes what happens, while if the school is giving me the information, okay, they sometimes if the marks of if the percentage are from 100 or our marks are from 100, sometimes by mistake they type it 101. So that is a misinformation. You cannot score 101 from 100, or it is 120 by mistake. So that is misinformation. So cleaning the data set means we are identifying the incorrect information and deleting that information so that we should analyze the proper data, and also filling the missing information. These are just the two types of examples I have given you to clean the data set, while there are many others as well. Okay, so once we have cleaned the data set, we are moving towards the next part, fourth step, that is analyze the data set. So in analyze the data set, there are different ways we can analyze. Data visualization is one way. Data visualization is about creating the graphs, creating the pictures from the data, creating different graphs with respect to different x-axis and y-axis, and coming up with that this particular like suppose in case of our example, I'm creating a graph which shows a particular student is good, is having maths. I will plot it with respect to different years. So I can see that he is continuously good at maths, continuously dropping in biology, continuously having good in economics as well. So like this, drawing a graph. So from the graph as well, we will come to know which student is good in which area. That is one way of doing the analysis. Other way is statistical analysis, to prove the things statistically. That I will tell you how to do that. Other is machine learning and deep learning. Deep learning is for the unstructured data. I will not go deep into these two techniques. We will concentrate on statistical analysis. So analyzing the data, so statistical analysis means we will perform ANOVA analysis, we will perform t-test, we will perform correlation, and based on that analysis, we will interpret the results. Interpret the results means you have to make a conclusion that this student will go, should go to economics university. Something like this. Okay. So this was about the complete data analysis process. Next is statistical analysis. Now, what comes under statistical analysis? The first thing that I'm talking about is the ANOVA test, that is analysis of variance. Now, what this analysis of variance means? Like ANOVA test is basically if you have two different rows. Like suppose we have age of the student and the marks of the student. But age and marks, we know from our understanding, from our basic sense, we can understand that age and marks of the students doesn't matter. But to prove it statistically, we have to perform the ANOVA analysis. Okay. So similarly, like marks of maths and marks of economics, are these two different columns in the data set are related? To check that, we have to perform the ANOVA analysis. So ANOVA is the basic statistical technique which is used to check whether two or more groups are significantly different from each other or are same. So what we are checking, two columns in the data set, two different, in the student data set, we have age, we have marks of maths, marks of science, marks of economics. So whether economics marks and maths marks are related or not, that we can prove with ANOVA analysis. Okay. So ANOVA analysis is just to prove that whether two or more groups are significantly different or same. That we have to prove. Then what is F statistics? F statistics is a measure if the means of different sample are significantly different or not. So when we are doing the ANOVA analysis, we will get the F score. So F score will show us, depending upon the F score, it will show us whether particular two features are same or two features are different. And the formula for it is F equals to between group variability and within group variability. So between group variability divided by within group variability. So this is the mathematical formula, but we will not go into the mathematics because deriving this formula will take almost half an hour and more. So just I had explain you that F statistic, based on the F statistics, we will do the analysis, or we have F statistics or we have P value that we will see. Now, for the analysis purpose, I am using one data set which is of heart disease. Okay, so in like I had given you the example of student data set, but this is the data set which I am using. It's an open source data set from UCI repository. That is a UCI machine learning repository has this data set. So it consists of 14 columns. Okay, now age. then gender, then CP, chest pain type, then thresh BPS, cholesterol, fasting blood sugar, ECG, maximum heart rate, exchange, then ST depression by old peak, slope, CA, THAL. These all are features. Depending upon these features, we have a target variable. Well, what is target variable? Target variable, if it is 0, it means no heart disease. And if it is 1, it is heart disease. You don't have to understand these terms. These are just an example I'm giving you. So this data set consists of 13 different factors. Based on it, we will decide whether our target is 0 or 1. Okay, so we are doing the analysis here. We are doing the data analysis. So we require some data. So I have taken this data. Okay, so now what are the hypothesis testing steps? Now, based on this data, heart disease data, we have to design some hypotheses to test. Okay, so what is hypothesis testing steps? We have first step is to form a null and alternative hypothesis. So you have a research question, like see here, my research question will be, what age group of people are having heart disease? Because age is related with heart disease. We can say that. Cholesterol is related with heart disease. We can say that. Then we can say that chest pain can be related to heart disease. Even which gender, which sex, male or female, has more heart disease. Okay, so we are relating each factor with a target variable having heart disease or not. So here my questions will be whether age is important to like whether age is having a same variability as that of target. It means they are significantly same or different. If they are significantly same, that it means that age has the huge impact on the heart disease. And if they are different, means age doesn't have huge impact on heart disease. That we have to prove. Whether age matters or not, whether sex matters or not, whether chest pain matters or not. These are the various features. Depending upon that, we have to test. Okay. So this is just a data set I have chosen to give you the example. Next is null hypotheses and alternate, like the hypothesis testing steps. Just I will make this here. So this is hypothesis testing steps. So there are 4 steps for hypothesis testing. Okay. So first is null and alternative hypotheses. So based on your research questions, you have to decide what will be your null hypothesis and what will be your alternate hypothesis. So your null hypothesis H0 will be the claim of no difference in the samples. And your alternate hypothesis claims H0 is false. So they both are like if this is true, this is false. If this is true, this is false. One of either null hypothesis can be true or alternative hypothesis. So we have to prove which hypothesis is true. Okay. Then we will test the test statistics. What is the test statistics that we have to do? A test statistic is a number calculated from your data that helps you decide whether to accept or reject the null hypothesis in the statistical test. So in the statistical test, we will get some value, which we will say, we will have some threshold value as well. I will tell you what is a threshold value, what is test statistics. Depending upon that value, we will decide whether we have to accept a null hypothesis or alternative hypothesis. Okay. The next is p-value and interpretation. Now, p-value is a probability in measure of how likely it is that any observed difference between groups is due to change. It means that P will give you a probability whether what is the observed difference between the 2 different columns or 2 different features, which is a change. If they are same, the p-value will be small. If they are different, the p-value will be large. Okay. So based on p-value, we can make a decision whether we have to accept the null hypothesis or the alternate hypothesis. And last is significance level. Significant level, a p-value measures the probability of obtaining the observed results, assuming that the null hypothesis is true. Okay, now significance level means we will, depending upon the p-value, we will say whether it is statistically significant or not. Okay, so lower the p-value, the greater the statistical significance of the observed difference. So if a p-value, we have a 0.05 as a threshold. We are talking about the threshold here, right? So my threshold is 0.05. This is not my threshold. This is the standard default threshold, which is set. So the p-value of 0.05 or lower is generally considered as statistically significant. Statistically significant means it has good relation. It has similarity. Okay. So now we are doing the hypothesis testing. Now see, in our case, first hypothesis that I have created is for age. Okay, age has low variance, thus has no impact on target variable. I'm saying that my null hypothesis is age has no impact on target variable, and H1 hypothesis, alternative hypothesis is age has high variance, thus having huge impact on target variable. Okay, now I'm performing this ANOVA analysis. Now this is the result obtained from SPSS. Okay, if the time permits, I will show you how we can generate the ANOVA analysis, but I don't think so because we have to cover many things. So just this is the screenshot which I have taken from the SPSS. SPSS is a tool for data analysis. So see, I have done the SPSS is a tool for data analysis, but it is paid one. Okay, so I will also tell you one free unpaid tool, that is Orange Data Analysis tool, which is freely available. So you can use it and you can see how you can use that and how you can perform the ANOVA analysis into it. But this is the result from SPSS. So in the SPSS, we have seen that F statistics. We got the F statistics, that is 16.11, and the significance is the p-value, that is 0.000, means the significance is 0. Now, what was our thumb rule for null hypothesis acceptance? If the p-value significance is greater than 0.05, then accept the null hypothesis, else reject. Okay. So now what is our significance? Significance is 0. 0 is less than 0.05. Then we have to reject the null hypothesis. Okay. So thus from this we have said that H01 is rejected. Hence age has impact on target variable. Okay, so age has huge impact on target variable. Our target variable was whether a person is having a disease, heart disease or not. Okay, so we already know age has the huge impact on heart disease. So this is also proved statistically. So that we have to show mathematically. Like we know many things. Cholesterol, if your cholesterol is high, you will have the heart disease. There are the chances, high chances of heart disease. We know that. But to prove it statistically based on the data is more important. So I have chosen this data set because everyone is aware about the heart disease, the factors which are responsible for heart disease. So that's why this data set was chosen. Okay. So age, from mathematically also we have proved that age has impact on target variable. Therefore, it is important for predicting a target variable. So if you want to predict the target variable, whether a person is having a heart disease or not, age plays very important role. Okay, so we have proved this statistically. Next is cholesterol. Cholesterol has low variance. My second hypothesis, null hypothesis, 0 means null hypothesis, 1 means alternate hypothesis. So my second hypothesis says cholesterol has no impact on target variable. And H1, alternate hypothesis is cholesterol has high variance, thus have huge impact on target variable. Now let's check. This is the results of the SPSS of ANOVA analysis. So here, this is F statistics 0.02 and significance is 0.1. Now, the p-value, the significance is 0.1, which is greater than 0.05. Okay, so we have to accept the null hypothesis. So null hypothesis is saying that cholesterol has no impact on target variable. But we know that cholesterol has the impact on target variable, some impact. Okay. But from the statistical analysis, it is proved that cholesterol is having no impact on target variable. Therefore, it is not important for predicting the whether a person is having a heart disease or not. Okay. So this analysis, ANOVA analysis, can be performed using the tools, different tools, or you can even use the Python coding. You can use the Python language to code and perform the ANOVA analysis. Okay. How to do that in the code or in the tool, that is different thing that will again take a 1 hour of session. So it will be tough for me to accept to teach you right now how to do this. But I am basically now concentrating on theoretical part, what is data analysis, how statistics is more important into it. Now, what we have observed from this, by doing the statistical analysis, we can analyze this data. This was the data given to us, which is having no meaning. Okay, age is given, then gender is given, then chest pain type is given, then these are the various features we are given, and the target variable is given to us. Now, on this data, what insights you can make? Whatever insights you can make, you have to give. Okay, so by doing different techniques, by analyzing different techniques like ANOVA analysis, we have come to this point that age is an important factor, while cholesterol is not. Okay, this was second. Now, this is the orange data mining tool. Yeah, if possible, I will show you the orange data mining tool, and I can show you this ANOVA analysis here. So that will be like you can understand. So orange data mining tool is a free tool. It's an unpaid tool. Okay, while SPSS is a paid one. So you have to pay and buy that tool, SPSS, and then you can perform the analysis. Well, orange, you can install it directly and you can use it. So we have, now what is feature importance? Now we have different features. We have different rows in the data, like CP, old peak, thallax, CA, slope, and all age. So among this, if we want to see which feature is more important based on ANOVA analysis, so we can see that CP is more important because it is having a high value of 69, while cholesterol is low, 2.2. Cholesterol is having low. So we have already, by doing the statistical analysis, we have already observed by doing the ANOVA analysis and creating the hypothesis testing. In the hypothesis testing, we have found that cholesterol is not much important for predicting the target variable, for predicting whether a person is having a heart disease or not. Okay, while other features, so which is the most important feature is CP. CP is chest pain. Chest pain is more important for predicting whether a person is having a heart disease or not. Okay, so these values are in descending order. The higher value is having more important, while the lowest value is having the least important. So this is about the feature importance that we have calculated. Now, correlation. Now, correlation Pearson method is again a method for feature importance. So just I will explain you what is correlation. Now, in the correlation, what we are doing, we are finding a relationship between the various features. Like in our data set, we are trying to find a relationship between age and chest pain, relationship between age and target variable, chest pain and target variable. What is the relation? How they are related? Whether they are positively related, whether they are negatively related. If they are positively related, what is the measure? Like whether it is highly positive related or low positive related. If it is negatively related, then what is the measure? High or low? That we can decide by using a Pearson correlation method. There are different correlation methods, but one of the famous method is a Pearson correlation method. Okay, so the Pearson correlation method is a type of correlation coefficient that represents a relationship between two variables or two features that you have to measure. Like if you want to see how two different features are related together, then correlation analysis is the most important analysis that we can perform. Okay, and the Pearson correlation is a measure of a strength. It shows a strength and association between the two continuous variables. So the variables should be continuous. Continuous means it shouldn't be categorical. Categorical, like see color. Color is not a, I'm just giving you an example. So two continuous variables, it should be two continuous variables. Like color has having the categories like red, blue, yellow. So it is known as categorical variable, while a continuous variable or numerical variable is the one which is having numbers. Okay, so this is about the Pearson correlation. Then Pearson coefficient is the mathematical correlation coefficient representing the relationship between two variables. Okay, so Pearson coefficient ranges from +1 to -1. Okay, so it is having a value from +1 to -1. So if it is +1, it indicates positive correlation. 1 is the highest and 0 is the lowest. Okay, if it is positive, it is having positive relationship. If it is having minus sign, it is having negative relationship. So the relationship positive and negative is decided by the plus and minus sign. Okay. So, and 0 has no relationship. The magnitude indicates the relationship strength, while the sign indicates the relationship direction, positive, negative, and the magnitude 0 0.5, 0 0.6, it shows that it has the 0 0.6 relationship, like it is more than half, good. 0 0.6 is more than half, so it is good. But the highest can be 1. Then other thing is Pearson correlation coefficient formula. This is the formula, how it is calculated mathematically. So this is R is represented for the coefficient of correlation. Then this is summation of xi minus x bar. What is now x bar? X bar is the mean of x variable. X variable and y is your target variable. Like in our case, having heart disease or not is my y variable, which is represented by target. And x bar is the age. Suppose age, cholesterol, that is my x variable. Okay, so x is the age, suppose y is the target. Xi and y are the samples of x and y, because there may be multiple samples, multiple rows in the data set. So this is one sample, xi and yi. So to calculate this, we are calculating xi minus x bar. X bar is the mean of the x. Then yi minus y bar. Y bar is the mean of y. And xi and yi are the particular samples of, like I can represent from 1 to n. N will be the number of samples in the data set. Okay, so this is like this. And it is under root of summation xi minus x bar square to yi minus y bar square. This is a formula, mathematical formula of how we can calculate the Pearson correlation coefficient. Okay, so now one thing we have to understand, like if we are performing the Pearson correlation, our value will range from +1 to -1, where the number, numerical number, will indicate a strength, while the sign will indicate a direction, positive or negative. Okay, the next thing is importance. What is the importance of correlation matrix? Now, what is the importance of doing the correlation? Correlation is very important statistical method other than ANOVA. So the first thing, if two variables are closely correlated, then we can predict one variable from another. Like suppose if age is highly correlated with the target variable, then to predict a target variable, age is an important factor. We will consider that. Then correlation plays a vital role in locating the important variables on which other variables are dependent. So by correlation, we will find that what are the top 3 important variables, what are the top 10 important variables in the data set, which we should consider to predict our target variable. So mostly correlation plays an important role in statistical analysis to get which feature is more important, which feature is not. It is used as a foundation for various modeling techniques. The modeling technique means where you want to use some models, you have to create the models, or you have to create a predictive, you have to do the predictive analysis. So in creating the machine learning models, then deep learning models, to have the feature selection, to select the features in the data set, because this data set that we have selected is having only 14 features. But in the real-time data, if I want to perform the statistical analysis in the real-time data, you have more than 100 variables. Some data sets have more than 200, 300 variables. So how we can handle so much variables together for the real-time analysis? That will be very tough. So it is important to check which features are important. So to do the modeling techniques, like to implement the machine learning for doing classification or for predicting something, then it is important to the feature selection. We cannot take 300 variables, 400 variables at once for modeling techniques. It is very tough. Okay, so the most important thing is you have to select some good features, and based on it, you have to create a model. So for feature selection, correlation is very important. That other correlation contributes towards the understanding of causal relationship, if any. Also, you will understand whether a particular variable is having a good relationship, good connection with the other variable. And if so, whether it is positive or negative, that we have seen. Okay, so this was about the importance of correlation. Now, this is again the correlation analysis from Orange tool. This is for Orange tool and this is for SPSS tool. So see here, I have taken three variables, age, target, and REST ECG. So how REST ECG is correlated with REST ECG, REST ECG, REST ECG 1, because it is same. So it will definitely be 1 because all values are same. REST ECG is correlated, positive correlation with 1 with high probability with REST ECG. Now, how REST ECG is correlated with target variable? It is having 0.137. Okay, which is positive. It is positive 0.1. But positive 0 means it is having a low. It is having low. Okay, 0.1 is low because 1 is the highest. Then REST ECG is correlated with how it is correlated with age. It is correlated with minus 0.116. So it is negative. It is correlating in the negative way. It is having a correlation in the inverse way. Okay. Then how target variable is correlated with REST ECG? 0.137. Same value will be here because we have already seen. How target variable is related with age? 0.0225. So it is in negative way. Okay. Now, in case of ANOVA, we haven't found whether it is correlated in positive way or negative way. Here we have found that it is correlated in the negative way. Okay. So it is giving more useful information than ANOVA analysis. Okay. Then how age is correlated with REST ECG? Minus 116 with target variable 0.2 and with age 1. This here in case of SPSS, you have to select the number of features. So I have selected this. Now, this is the correlation. This screenshot is the correlation from Orange tool. I have used the Pearson correlation and I have correlated with age. I have not correlated with target. How age is correlated with Thalash? It is 0.0399. How age is correlated with Thresh BPS plus 0.27. So these are the values which are given. I am correlating age with the various other factors. Okay. So this was about the correlation and ANOVA analysis. So now if you want, we have a time, I will show you how we can perform this analysis in the Orange tool. Okay. So I will open the Orange tool. It will take some time to load. Can you see my screen, everyone? Can you see my screen?
Yes, we see Orange tool and SPSS.
You can't see the Orange tool. Welcome to Orange tool.
We see a black box opening up, but we don't see anything in it yet.
Okay, just a minute. I will stop sharing and I will share it again. That will be better, I think. Share the complete screen. That will be better. Yeah. Can you see now? Welcome to Orange.
Yes.
Yeah. So this is the Orange tool, which is installed in my system. So you have to install it, and it is unpaid. It is freely available. So this is, if I want to create a new data set, I want to load a new data set, I will give on new.
Priyanka I, do you have a link to download that?
Sure, I will just message you. Should I message it right now? Because I have to search it on Google.
You can put it right into chat. That way the students can just click on the link and download it.
Okay, but right now it won't be possible because to do with me on hands-on, I think it will take time for them.
Okay.
So I will just explain them and I will share the link also. So you can download, and if you have any doubts, you can contact me later. I think that will be good. Okay, so this is the file. If I want to load the data set, there are different ways to load the data set. Someone is raising a hand. Just a minute. So do you have any questions? I think let me complete this, then we can have a question answering session. Okay, so we are having a file. So there are different way to load the data set. One is file, CSV file, data set. So if I want to load a data set, already I have installed this heart disease data set in my system. So I will load it. It is in my folder in somewhere, I think it is in my folder. So I have already the heart disease data set, heart.csv, that I have loaded here. So you can see all those variables that I was talking about: age, sex, CP, cholesterol, BPS, then FPS, all, and target. My target is my variable, which is 0 means no heart disease, 1 means heart disease. Okay, so now I want to do the analysis. Okay, how to do the statistical analysis? If you want to perform the correlation analysis, then you have to go for rank. Rank is the one where you can perform the correlation analysis. And if you want to see the feature statistics, this is the feature statistics. So just you have to drag and drop. I have drag and drop this feature statistics here, and it's done. Okay. Now if you want to connect this data to this picture, just pull the line and add it. So now the data will be represented in the feature statistics. So you can see the mean, you can see the median, you can see the dispersion, minimum value, what are the missing values, what is the maximum value, everything. This is a complete statistical analysis of your data. And here you can see there are two different colors showing here, blue and red. Why two colors only? Because we have two variables. Target variable is having two, 0 and 1. No heart disease and heart disease. Okay, so here I am selected the target variable. So I am having 0 and blue and red, 0 and 1. So you can see how they are divided, like how the distribution of these variables has been done with respect to REST ECG, then how it is done in CA, how it is done in chest pain. This complete analysis is being given here. Okay, and also it is given whether this particular column is having the missing values. So it is having 0 missing values. I was talking about cleaning the data set. So if it has a missing value, we have to clean the data set. We have to remove the missing values. So it's also giving you how many missing values are there. Also, what is the mean? What is the mean value? Mean means average of the values of REST ECG. So it is 0.53, 0.73. This is a complete statistical analysis that has been given here. Okay. Then rank. Rank is about correlation. So if I'm just bringing an arrow from here to here, I will get a rank. So see, this is relief F method. I will go with ANOVA. Okay. So now ANOVA is not applicable. Why ANOVA is not applicable here? Because these consist of numerical as well as categorical variables. So you have to remove the categorical variables if you want to go with ANOVA. So I will only select see, this is categorical variable. Okay, so categorical variables are not allowed in ANOVA. So if you want the ANOVA analysis, then you have to select only the particular columns. So I will drop this select particular columns, and then I will go with ANOVA analysis. So first I will do it. Click here. Okay, then select columns. I have to select age, filter, ignored. Yes, categorical are ignored. And this is then, okay, done. So I have ignored the 3 categorical columns, only selected are numerical. So if now I will remove this link. Now I will just only give the numerical columns to the rank. If I will give the numerical columns to the rank, we have the ANOVA analysis for it. So for the target variable, the ANOVA, this is the results. So for the target variable, the highest value, which is having the more importance, is chest pain. The second importance is old peak. Okay. Have you understood? Like if I'm giving a complete file to the rank, to the ANOVA analysis, it was giving not applicable. The reason was it was having the 3 categorical variables. Sex is the categorical variable, means gender. Gender is having male and female. There are only 2 categories. That is categorical variable. Okay. Numerical variables are the one which are having age. Age is a numerical because it can be like 53, it can be 42, it can be 35, it can be 20. Age have it's a numerical value. Even chest pain can be a numerical value. Intensity of chest pain. Cholesterol has a numerical value. Okay, all these are numerical values. So ANOVA, the disadvantage of ANOVA is that you cannot have the categorical variables into it. Okay, you have to only take the numerical variables for the correlation. So this is the thing. Now here, if you want to go for, there are different methods as well. Like ANOVA is one, Gini, information gain, relief F, there are X square. These are the various correlation methods that also you can perform. Okay. Next, if you want to explore more into this, there are many things that we can explore. Even we can do the data visualization. I have talked about the data visualization, how to do the analysis by using the graphs. So see, we can have a scatter plot. This is a visualization tab. I have just dropped the scatter plot and I will just click on the data here. Okay. So if I will click on the scatter plot, see, you can see there are two. 0 means no disease and 1 means disease. Okay, so just I will move this. Now we have, this is age. Okay, with respect to age. Now we will see which age group is having more heart disease. Okay, so see, this is for heart disease. If you can see this group, this age group is having more samples as compared to here. Like, so the one with 76, 74, 72, after 72, it is no heart disease, and even the samples with heart disease are very low. So this age group, like you can see from up to, I can say particularly this age group. So from here, from consider 40 to 60. So from 40 to 60 age group is having more heart disease. So this can be done using the data visualization. Here we are not doing any statistical analysis. Here we are visualizing the data and we are predicting, we are making the interpretations. So from this we can see this 40 to 60 age group is having more heart disease as compared to the other age groups. Here you can change the value like male or female, which is having more heart disease. So the sex. You can see that as compared to, this is for heart disease. This is 0. I think 0 is male and 1 is female. So as compared to male, females are having more heart disease. Okay. So you can just change various cholesterol levels. So you can see if the cholesterol level is between, this is more. So like see, in cholesterol is not important. You can see most of the samples are between 180 to 340 for no heart disease and for heart disease. This is for heart disease. Red means 1, it is heart disease, and blue is no heart disease. And cholesterol range for both is similar. So that's why also during statistical analysis, we have observed that cholesterol is having no impact on predicting the target variable. And similarly, we can observe in data visualization as well. Okay, clear? So this is the way you can make your analysis by data visualization, by statistical analysis, and you can merge your analysis, merge your interpretations to prove your point. And when you if you are doing a research work, in a research, you have to prove your point with different techniques. Only by doing data analysis, you cannot prove your point. So to prove your hypothesis, you have to do statistical analysis, you have to perform the data visualizations like this, and you have to prove that cholesterol was having no impact in predicting the target variable, that is having heart disease or not, with statistical analysis as well as in the visualization. So this is the way you can prove your point. The other thing that I will show to you, there are various plots. Even you can have linear projections where you can have 3 different just that. Actually, it got hanged due to the load because call is going on. Okay, yeah, done. So I'm here. So this is a linear projection. Here I have cholesterol and age, and I will take one other variable, CP. How cholesterol, age, and CP are related. So this can be shown. So this is the age, this is the cholesterol line, and this is CP line, that is chest pain. And you can see red are disease one, and 0 are having not disease. So you can see how they are collaborated. Like from linear projection for this data set, we cannot make major decisions because this all samples are having in the middle. All samples are at the same place. So we cannot make much decisions on it. Okay, so these are we have a Boylan plot. In Boylan plot, we can see, I will show you an example how we can prove age. Like we have seen age has important factor with statistical analysis. So Boylan plot will show you how age. Now see, age and target. This is the target and this is age. Now this is the mean. Blue means it's having no heart disease, and red means is having heart disease. So see, what is the mean age of the person who are having the heart disease? The mean age of the person is, this is the mean value, this dot. So the mean age of the person, I can say it is 52 to 53. So most of the people, average age of the people of having the heart disease is 52 to 53. So here we have come up with some value. From the data, we have come up with some numerical value that particular age group on an average is having a heart disease. And if you want to see, so you can just have this line, like from this point, 30 to, you can say 78. The person from 30 to 78 is are at more risk to heart disease. While the one who are not having the heart disease are in the range from 52 to 72. So this is the way we are making the analysis, and we are creating the numerical values in statistical analysis. So these values are also very important when you are doing some research work and you are showing some statistical analysis for your data.